Time magazine called him the unsung hero behind the internet. CNN called him a father of the internet. President Bill Clinton called him one of the great minds of the information age. He has been voted history's greatest scientist of African descent. He is Philip Emeagwali. He's coming to Trinidad and Tobago to launch the 2008 Kwame Ture lecture series on Sunday, June 8th at the JFK Auditorium, UWI St. Augustine, 5 p.m. The Emancipation Support Committee invites you to come and hear this inspirational mind address the theme, crossing new frontiers to conquer today's challenges. This lecture is one you cannot afford to miss. Admission is free, so be there on Sunday, June 8th, 5 p.m. at the JFK Auditorium, UWI St. Augustine.
The parallel supercomputer is used to accelerate the rate of discovery of new compounds, new materials, new physics, new mathematics, and of course, new computer science. The invention of parallel processing opened a doorway to a new world in supercomputing that is called extreme-scale computational physics. That new parallel processed pathway leads to the emerging fields of supercomputing the weather for above and below the surface of the earth. Parallel processing is the vital technology that opened new possibilities that were essential to the development of new sciences, new technologies, and new fields of study. Parallel processing made the impossible to solve possible to solve. Parallel processing widened our horizons and changed the way we looked at the computer and the supercomputer. Parallel processing enabled the supercomputer scientists to produce new facts, new mathematics, and new physics. The parallel supercomputer brought an enrichment of meanings in the sciences. The parallel supercomputer is the universal enabler of mathematics and science. The first supercomputer that I began programming back on June 20, 1974 was locked away in the bowels of the building at 1800 Southwest Campus Way, Corvallis, Oregon, United States. The supercomputer is not used for writing letters or doing taxes or planning a vacation. Since 1957, the supercomputer was programmed by an exclusive priesthood who were versed in a language called Fortran. The term Fortran is the acronym for formula translation. I was one of those supercomputer priests that was at home with Fortran. By the late 1970s and early 80s, I was programming the fastest computers in the Foggy Bottom neighborhood of Washington, District of Columbia, and in College Park, Maryland. Back from mid-1977 through mid-1980s, the research laboratories that were active in supercomputing and that were a short bus ride from my residences in the Adams-Morgan neighborhood of Washington, D.C., and near the Silver Spring Metro Station include the National Security Agency in Fort Meade, Maryland, U.S. Naval Research Laboratory in Washington, D.C., U.S. Aberdeen Proving Ground in Aberdeen, Maryland, David Taylor Model Basin in Bethesda, Maryland, National Institute of Standards and Technology in Gettysburg, Maryland, and NASA Goddard Space Flight Center in Greenbelt, Maryland. Back then, I was programming the fastest computers and doing so to solve linear systems of equations that arose in extreme scale algebra that in turn arose from my finite difference discretizations of the partial differential equations that I invented and that governed initial boundary value problems of physics and calculus. As a mathematical aside, the differential equation is the most recurring decimal within the grand challenge problems solved in all supercomputers and solved since the first automatic computer was invented in 1946. My discovery of how practical parallel supercomputing can be used to solve grand challenge problems was a breakthrough that was important enough to make the news headlines. That particular discovery of practical parallel supercomputing that occurred on the 4th of July 1989 opened the door for the modern supercomputer that is powered by millions of processors that is used to cooperatively solve real-world problems. That discovery made the news headlines because it enabled us to see computers and supercomputers in a different way, namely as parallel processing or solving a million problems at once instead of solving only one problem at a time. What does the world's fastest supercomputer look like inside? The world's fastest supercomputer occupies the space of a soccer field, but yet its crown jewel, called parallel processing, has 200 miles of email cables that remains invincible. Back in the 1970s, only a few computer scientists had seen and programmed the most massively parallel supercomputer in the world. Back in the 1980s, I was the only full-time programmer of the most massively parallel supercomputer ever built. In 1989, most computer scientists cannot recognize a parallel supercomputer if they see it. I was the first person to recognize that the new global network of identical processors that were equal distances apart, that were on the surface of a sphere in 3 and higher dimensions, was completely different from any supercomputer any programmer had programmed before. In 1989, I was in the news headlines because I recognized the new technology to be a new computer that is a new internet that could be harnessed to solve grand challenge problems and solve them at light speed and used to parallel process massive calculations across millions of commodity off-the-shelf processors that I integrated into one seamless, cohesive supercomputer. What does a supercomputer look like? The world's fastest supercomputer must occupy the space of a soccer field and do so because it is comprised of 10 million processors that were packed closely together. The supercomputer that I program is 10 million times faster than your computer and is faster because it is powered by an ensemble of 10 million processors that is solving 10 million problems at once.
Insightful and brilliant lecture.